Hi students, welcome to the ABK chemistry channel. So in the previous video already we did about the integrated rate equation of a zero order reaction. Now in this video I am going to doing integrated rate equation of a first order reaction. So before going to discuss about this one, please subscribe the ABK chemistry channel and activate the bell notification icon for further updates. Okay. So what are the basics required for integrated rate equation? Already I did in that integrated rate equation of first order reaction video. So first watch that one and come to next this video. Okay. Now come to the directly I am going to entering the integrated rate equation of first order reaction. So if you take one general reaction, the reactants will be converted into products. Is it or not? So the rate for this general reaction, how can you write rate equation? Rate is directly proportional to concentration of a reactants. Rate is directly proportional to concentration of reactants. Rate is nothing but rate of reaction. Now, I mean concentration of reactants power 1 I am going to taking. Why? Because it is a first order reaction. Power 1 I am going to taking. Now the rate is equals to K into directly proportionality I am removing. I am taking one constant. And now any power 1 will becomes to same value. So the concentration of reactants as usual it will becomes here. Now here what is the K is there? The K is known as a rate constant. K is known as a rate constant. Now how can you write the differential rate equation for rate? Decrease in the concentration of reactants with small change in time. Okay, is equals to K into concentration of reactants. K into concentration of reactants. Very simple. Minus dt what is there? Or you have to multiply. You can multiply with negative charge on both sides. We can get the next step. Or otherwise directly I am sending this minus dt this side, concentration of reactants I am taking this side. So what it will becomes to, I mean change in the concentration of reactants with the concentration of reactants is equals to minus dt I am going to sending this side. Already K is there here, K is there, minus it will becomes minus K into dt, minus K into dt. And it is differential rate equation. Already in the previous video I did the differential rate equation does not provide the clear information about any other reaction generally. That's why to this differential rate equation, this is the differential rate equation another form. To this differential rate equation what I am going to doing students? Integration I am going to doing here. Integration on both sides. Integration on both sides. Okay. So what we are getting here? Integration of or change in the concentration of reactants divided by concentration of reactants is equals to minus K. K is a constant. To the constant we don't do any integration. And now integration of which one? No, dt I am going to doing. Okay. Now here keep in your mind students. This is integration students. Okay. Now this is integration. Now here keep in your mind students. I'm writing one formula from integrations. Integration of d of x divided by x is equals to ln x. Keep in your mind that formula. Okay. Integration of d of x divided by x is equals to ln x. Here integration of d of x divided by x is equals to what I am going to writing? ln x. X is equals to concentration of reactants here. Keep in your mind. So that is ln concentration of reactants. This total will becomes to this one is equals to minus k into integration differential get cancelled and here k t, what is the remaining t is the t I am going to taking plus I. Why I? Once I am doing integration I am going to taking integration constant. So this one I am going to taking as a equation 1. This one I am going to taking as a equation 1. Keep in your mind students. Equation 1. Okay. It is a formula students. Don't forget. Now after this listen students. What are the conditions? At time is equals to 0, time is equals to 0, still the reaction is not started. That time the concentration of reactants is equals to present in initial state. Initial state. Concentration of reactants are present in initial state, it is present, initial state. Starting. T is equals to 0 means still the reaction is not started. How much reactants were taken? That much reactants as usually it is present. Okay. Now substitute T value and concentration of reactants values in equation 1. What is the equation 1? This is equation 1. What I am going to taking? ln concentration of reactants is there. In concentration of reactants, I am substituting initial concentration. That is, initial concentration of reactants is equals to minus K into, in the place of T, I am going to substituting 0 plus I. Minus K into 0 will becomes to 0. What is the remaining part is there? Ln initial concentration of reactant is equals to I. This one I am going to taking as a equation 2. This one I am taking as a equation 2. Now substitute to equation 2 in equation 1. What is the I value I got here? That value I am going to substituting here in the place of 1. Okay, what I am getting, students, here? Ln initial concentration of reactant is equals to minus Kt plus I is there na? In the place of I am substituting this one, Ln initial concentration of reactants. Okay, this is very important formula. Later I will tell about this one. Now very important. From this formula we are going to derive the all graphs of first order reaction. Keep in mind, students. Later we can discuss about this one. It is a special formula. Keep in mind. It is, I am going to taking as a equation 3. Okay, this is equation 3. Very important formula. Okay, after this, what I am doing here, minus Kt I am going to bringing this side. It will becomes to plus Kt, and Ln concentration of reactants I am sending to the side. What happens this side? Kt is equals to Ln initial concentration of reactants minus, this will be goes to that side, that is Ln concentration of reactants. You have to keep in mind. Okay, now Kt is equals to, here I am going to writing one formula, Ln A minus Ln B is equals to Ln A by B. That is one formula. Is it log A minus log B is equals to log A by B, like that? Ln A minus Ln B is equals to Ln A by B. Here Ln A minus Ln B is there. So Ln A divided by Ln B it will becomes. Kt is equals to Ln initial concentration of reactants divided by concentration of reactants. Okay. Now here listen carefully. I mean K is equals to 1 by T. I am sending T is this side. 1 by T I am sending this side. Ln initial concentration of reactants divided by concentration of reactants I am taking. Now here 1 Ln is equals to 2.303 log. Keep in mind, Ln is equals to 2.303 log. Very important relation. Now what is their Ln here? In the place of Ln I am substituting what? 2.303 log. So K is equals to 2.303 divided by T log. In the place of Ln I am substituting 2.303 log. Initial concentration of reactants divided by concentration of reactants. Very important formula. This is I am going to taking as a equation 4. This is the integrated rate equation for which order reaction? First order reaction. K is equals to 2.303 by T log initial concentration of reactant divided by concentration of reactants. Very important form. What is the integrated rate equation of zero order reaction? K is equals to initial concentration of reactant R naught minus R divided by T. Here K is equals to 2.303 by T log initial concentration divided by concentration of reactants. Okay, students, this formula is also written in another form, you know. So I am erasing this one, this part only I am erasing it. Okay, what is the another form of that formula is nothing but, for example, I am going to taking A reactants are converted into, for example, products. A is nothing but reactants. A is nothing but which one? Reactants. A is giving rise to products. Now here, at a time is equals to 0, my students, at time is equals to 0, concentration of A is I am going to taking as C, and concentration of products I am going to taking as, generally if you take the reactants will be converted into R will be converted into P, reactants will be converted into products. Concentration of reactants I am taking C, concentration of products is 0. Why? Because time is equals to 0 now, still reaction is not started. How much concentration of reactants is there? That much as usually it is there. Products concentration is 0. After time is equals to some time, on 5 minutes, so 10 minutes, so whatever it may be, after time is equals to T1, the concentration of reactants will be decreases some amount. Is it or not? some amount it will be decreases. That is, I am going to taking that one is a X. That one is a X. Concentration of reactants, can I take A? I mean, that is A minus X side will decreases. And it will be formed, some X it will be formed. We don't want concentration of products. And some concentration of reactants, what happens? Decreases. If time is going on, reactants will be converted into products, and the concentration of reactants is little bit decreases. What is the decreases? That I am taking as a minus X. A is the initial concentration. Okay. Then by based on this equation, how can you write? That is K is equals to 2.303 divided by T log initial concentration of reactants means initial concentration A divided by final concentration of reactants, that is A minus X. A minus X. This is also another relation. This is also another relation. We can write either this equation or this equation. K is equals to 2.303 by T log initial concentration divided by concentration of reactants. K is equals to 2.303 by T log A by A minus X. 90% completed, that is 100 minus 90. 80% completed, that is 100 divided by 100 minus 80, that is 20. Okay, like that. How much completed, that much you have to take here. Okay, students. So this is the integrated rate equation of which order reaction? First order reaction. Keep in your mind this formula. In next video, I am going to doing the all graphs related first order reaction. Very, very important. So in this video, the time duration will be taken more for video. That's why I am doing the next video. Don't forget to watch, students. Okay, thank you. From equation 3, what is equation 3? ln r is equals to minus kt plus ln r naught. From this video, I am going to doing all graphs. 4 graphs are there. With derivation, I am going to doing. Don't forget to watch. Thank you. Thank you so much.